Good morning, precalc fans. How are we doing on this fine Monday morning? Welcome back from spring break. I enjoyed my time down in the ocean. Got a little sunburn here and there, but it's okay. We are coming back from spring break now. I hope all is going well with your family. I hope you're staying illness free. I hope your family is staying illness free. Hopefully you've had some time off that you've been able to maybe do some socializing, FaceTime somebody, things of that sort. Do things to keep yourself occupied and also be able to socialize with some people. Continue to keep your social distancing. Once again, it is helping, and once again, hopefully we can get back to some sort of normalcy at some point. But once again, I hope you're doing well. Hope you're feeling well. We are going to do lessons till we come back in this manner. It is okay. You'll be able to do it. You'll be like you sitting here in the classroom. I will do my lessons just like I typically have done my lessons. I have put notes online for you. You can just print off the notes and you can follow along with the notes. If I go too fast, if I'm going too fast through this, how you solve this is you just hit the pause button, okay? And I promise I won't continue to talk when the pause button is on, okay? Just hit pause, and then you'll be able to, then whenever you're ready, you can push play again and you can catch up to where I'm at that point. So me doing the notes here will be very similar to you sitting in here in the classroom and taking notes. The nice thing about it for you is you could shut me up at some time by just hitting pause, okay? So that's an advantage of you. You could shut me up at that point. If you have any questions as we go through these processes, please do email me the questions. I will answer back to you as quickly as possible. I know I have some office hour times from 12 to 1. I'm still trying to figure out Google Meet, so I may not be there quite yet, but as we go through this process, hopefully we can get to a Google Meet where you can join a classroom and talk to me at that point. I'm not quite there yet with respect to this. So if you do have questions, I'll be there. If you want to send me a comment at that point, I can answer your comments, and individually with respect to your comments, feel free to comment me at any time. I will post any type of homework online. You can print that off. I'll post solutions. Once again, with the worksheets, I'll be very similar to what you have been doing here in classroom. So you can have access to the solutions, you can have access to the worksheets. What we do here for the fourth 9 weeks in pre-calc class is we go back and relive our fond memories of trig. Oh yeah, fond memories of trig and our good old buddy Pythagoras. Pythagoras is still around. We're a part of the Pythagorean Brotherhood. We are there, okay? So we will have trigonometry for the fourth 9 weeks here. The one thing that's nice for you is we won't do any trig identities. Darn, no trig identities. But what we will do is we'll go through some of the basic ideas of trigonometry. And if you take a pre-calculus class in college, what you will see is the exact same thing. You will see a portion of the algebraic world that we've done here in the classroom, but then you'll also see some trigonometry in the pre-calc world. So you'll see, revisit the pre-calculus, what you will see, and you'll realize as we go through trigonometry is you may not remember everything, but as we go through it, you may sit there and go, oh yeah, now I remember that. Now I remember that. And once again, the nice thing for you is I won't go through trig identities. I might go through a little application, I'm not quite sure. But I won't go through any type of trig identities. We may solve a couple trig equations, that's about it. So what we're going to be dealing with today is we're going to go back and review some of the ideas that we have in trig. Once again, you can print your notes down, you can write the notes as I go along. If I go too fast, just hit pause, okay? And then we'll go back and then you can hit play again and you can go back and start up where we're at. When we're talking about periodic functions, when we talk about trigonometry, sine, cosine, tangent, secant, cosecant, cotangent, these are periodic functions. We've dealt with algebraic functions. These are periodic functions. Function values are y values that will repeat repeat over a certain domain. Okay, as we go over a specific domain, the pattern that we will go through, the pattern of the function, the pattern of the graph will continue to repeat itself. That's the idea of a periodic function. It just repeats itself. In geometry, we talked about angles are formed by two rays connected at their endpoints. That was our definition in geometry. And when you're over there down the hallway in Dr. Clark's class, when we are in trigonometry, we define them as maybe. My smartboard must have been on spring break too. There we go. Used to measure the amount of rotation of a ray. The variables we use is with theta, alpha, beta, any type of Greek symbols that we use, that's what we use. So what we have here is we use trigonometry. Our definition is the amount of rotation of a ray. Okay, so we're rotating a ray, and if you remember back, we looked at the clock, and the clock, Mickey's big hands and little hands, and the clock hands there. Those were rotations about a central point. And I guess we said the amount of rotation of a ray about its endpoint. Guess I can put that in there also. So we're going to rotate a ray about its endpoint. We're going to hold the tail of the ray, the endpoint of the ray, and we're going to spin the ray around the endpoint. The initial side. It's the point at which the angle of rotation starts. Once again, I will go through this pretty quick, and if you need me to slow down, I'll just push pause. I'm trying to slow down or reduce the amount of download I have to do to YouTube here. So the point at which the angle of rotation starts, and then we have the terminal side. The point at which the angle of rotation stops. Okay, so we have the point at which it stops at the terminal side, and then we have the initial side. So if we take a look at a ray, here's a ray. This is your initial side. And we're going to rotate this ray. So this is our rotation. To a terminal side. That's our amount of rotation to a terminal side. This here forms what we call the angle. And this angle can be symbolized by any Greek alphabet letter, but the ones typically I will use a lot is the value of theta, which is a circle with a line through it. But alpha and beta are also used quite a bit. The vertex, when you talk about the angle of the standard position, the vertex, the angle is at the origin. The initial side of the angle is on the positive x-axis. The clockwise rotation was positive, clockwise was negative, and counterclockwise rotation is positive. And these are all things that we did back in trig class. This was the very first thing we did in trig. So, when we take a look at a 40-degree angle, if we're going to draw a 40-degree angle, here's our initial side. Vertex angle is at the origin, so here's our vertex. Initial side is on the positive x-axis. There we have the positive x-axis. And what we're going to do is we are going to rotate. We're going to rotate this 140 degrees. Our theta is 140 degrees. So we're going to take this and we're going to rotate it. This goes 90. This is 180. So we're somewhere in between here. So this is our rotation of 140 degrees. Okay, we are going counterclockwise because we have a positive angle. When we have negative 140 degrees, we have negative 140 degrees. we're going to rotate this negative, which means clockwise. There's negative 90, there's negative 180, so we're somewhere in this area. So this would be theta equals negative 140 degrees. And the hope is that as we go through this a second time, you tend to pick it up a little bit quicker because these are all things that we did in trig class. 420 degrees, what I want you to do is I want you to hit the pause button. I want you to draw a 420 degree angle. Okay, draw a 420 degree angle. So hit your pause button and draw your 140 degree angle right now. Okay, going 420 degrees. If we go one time all the way around, that's going to be 360 degrees. This is 450 degrees. 420 degrees will be somewhere in this range. So 420 degrees would be one whole time around, and we'd end up in quadrant number 1 with 420 degrees. We talk about the reference angle. It's a positive acute angle formed by the x-axis and the terminal side of our angle. So we're looking at the angle that's formed by the terminal side and the x-axis. Now, it does not matter if it's positive x-axis or negative x-axis. It's just the terminal side and the x-axis. This is going to be positive, it's going to be acute. It could be 90 degrees. So I guess it could be right angle also. That's formed with the x-axis and the terminal side. What I want you to find is find the reference angle of our angles up here. Find the reference angle from these angles here. So what we're looking at is we are looking at the angle that's formed by the terminal side, which is here, and the x-axis. It does not matter if it's a positive x-axis or negative x-axis. We're just looking for this measure of this angle. So our angle here is going to be, this is 140 degrees, going down here would be 180 degrees. So this angle that's formed by this would be 40 degrees, and this is your reference angle. If we come over here, here's my terminal side, here's my x-axis. So once again, this is going to be your reference angle, and this also will be 40 degrees. Okay, go ahead and find 420 degrees, hit your pause button, find it, hit your go button again, and come back and check your answer for 420 degrees. Here's my terminal side, here's my x-axis, so here's my reference angle. To go here to here is 360 degrees, so we had to go an extra 60 degrees up here to get to 420, so our reference angle is 460 degrees. We have degrees, minutes, and seconds when you're talking about an angle. Before the advent of the calculator and the usage, high usage of this calculator, they had to utilize the idea of degrees, minutes, and seconds. That was the partials of an angle. Okay, so back before the calculators, before we could type in the decimal, they just had to use decimals of an angle, and they had a table that you had to go and pull off your values from that table to be able to do any type of calculations. So we're going to go through the idea, and there's still people that still utilize them. Okay, 1 degree is equal to 60 minutes, and how we relate the idea of minutes is with 1 slash, and just like on a clock, 1 minute is equal to 60 seconds. And how we signify 60 seconds is a double hash there. What I want to do is I want to convert this decimal to, or this to a decimal. Well, when we talk about 41 minutes, that is a part of an entire. So how we can change this first into a fraction, it's easier to change it into a fraction, is we can write this as 27 degrees, and we can write 41 over 60 because that is the part of the fraction. Okay, part of the, this is the part and this is the entire. So we can just put it over 60 degrees, and then we have a decimal that we can sit there and calculate what is 41 divided by our fraction, 41 divided by 60, and we get 0.683. Taking our 41 divided by 60, so we have 27.683, and that's a repeater. If we take a look at what we have here, we have 57 degrees, 21 minutes, and 18 seconds. So we have 57 degrees, then my partial here is 21 over 60, and this is all addition. Now the question is how we deal with this 18 seconds. Well, how many seconds are going to be in a degree? Well, there's 60 seconds in a minute, and then 60 minutes in a degree. So if we take 60 times 60, we get 3600. So what we're able to do is take this 18 and divide it by 3600. So we create two different fractions here, and we can once again clickety-clack it through the calculator, and you can type that straight in. I can go 57 plus 21 divided by 60 plus 18 divided by 3600. And what we should come down to is 57.355. So that's how we convert a degree minute seconds back into degree, or I'm sorry, degree minute seconds back into just a decimal here. Let's convert the decimal into degree minute seconds. Well, once again, this is a partial of a degree. Well, what we did here, if we think about what we did here, to go from degrees minutes to decimals, we divided this by 60. Well, the 37 is fine. We're fine with that. What we had to do is take this decimal and change it into minutes and seconds. Well, if we divided 41 by 60 to get the 0.683 repeat, well, it should be what undoes the idea of division. It is the idea of multiplication. So what we're able to do is take this 71 minutes, or 0.71, and multiply it by 60. If we take this and multiply it by 60, so we have 0.71 times 60, what we get is we get 42.6. So this 42 is your number of minutes. So we have 42 minutes here, but we still have this 0.6 that we have to change also into seconds. So we take the 0.6 and multiply it by 60 again. And we get 36. And this is the number of seconds. So what we have here is 37 degrees, 42 minutes, and 36 seconds. What I want you to do is I want you once again to hit your pause button. Okay, before you hit your pause button, here's instructions. You're going to do this problem. Okay, and then you're going to turn it back on and see if you did it correctly. So go ahead and go through the exact same process here that we just did. Hit your and then turn your go to your go button again and turn your video back on and see if you've done it correctly. So what we have here is we have 37 degrees, 0.413. So we have 0.413 times 60. This gives me 24.78. So we have 24 minutes. And then we have the 0.78 that we have to multiply it by 60 again, because this is 0.78 of a minute, so we have to convert this into a second. So we have 0.78 times 60, so we get 46.8. And that's seconds, and that's as far as we can go with this. We don't go nanoseconds or milliseconds. So our measure in degrees, minutes, seconds is 37 degrees, 24 minutes, and 46.8 seconds. So that's able to convert degrees, minutes, seconds into decimals, and decimals back into degree, minutes, second. Once again, if I'm going too fast, hit your pause button. We also talked about the idea of radians. Okay, we had two different types of degree measures that we worked with. We had degrees, and we also had radians, because we know when we get to upper level mathematics and calculus, degrees start to fall apart. So we had to be able to convert and do things a little bit differently. So we have what is called a unit circle. Maybe. It's a circle with a radius of 1 unit. The circumference is the distance around the circle. And hopefully you start to recall this stuff from what we did in trig class. Then we have the radians. The radians are the arc length on a unit circle for a specific central angle. It's a portion of the circle and the interior of the central angle. So you have the arc length on a unit circle for a specific central angle, the portion of the circle and the interior of the central angle. Once again, to go back and define the idea of a central angle, it's an angle whose vertex is at the center of the circle. And this is a definition that you did when you were back in geometry. When you have a central angle, it's an angle whose vertex is at the center of the circle. The arc length on a unit circle. Once again, a unit circle is a circle with a radius of 1 unit, which is 1 inch, 1 meter, 1 mile, does not matter, 1 centimeter, 1 unit. Whatever that unit is, the radius is the 1 unit. So if we take a look at the circumference, how we calculate the circumference of a circle, if you remember, is calculated by 2 pi times the radius. Well, if I take a look at the idea of a unit circle, the radius is equal to 1. So the circumference around a unit circle is just equal to 2 pi. Now we'll just, yes, I know, we can approximate 3.14157182818, blah, 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 blah. Okay, I know we can do that. We'll just leave it as 2 pi right now, because we have a pi button on our calculator. If we need it, we can pull it out, but this is more than acceptable to say this is just the units of 2 pi. So if we take a look at an arc length, okay, of a central angle. Once again, hopefully you remember these ideas that we have talked about here, or you can recall it. If we had a central angle that spun all the way around, this is just spun around 360 degrees. Well, what we're taking a look at with respect to the radians is what is this arc length of going all the way around the circle? Well, that arc length is the entire circumference of the circle. So the number of radians, which is the amount of this arc length that we did to go around the circle, is equal to 2 pi radians. That is this entire measure right there. If we take our central angle and just rotate it to here, well, what we have rotated is we have rotated a total of 180 degrees. Well, if the entire distance around the circle is 2 pi radians, we just went half of that to get to 180 degrees. So how many radians do we have? Half of 2 pi, which is just pi. So this is pi radians. And that's the measure of this arc length right here. What is the measure of this arc length? Well, if we just rotated from here up to here. So now what we have rotated is we have rotated 90 degrees. The question is, what is this arc length right here? Because that is what we are measuring. When you're measuring the amount of radians, you're measuring this arc length that we have right there. Well, what is half of pi? Well, half of pi is just pi, 1/2 pi. So this is 1/2 pi radians, which is written as pi over 2 radians. So there's pi over 2 radians. And once again, hopefully the hope is that you are starting to recall this. Well, if we rotated just 60 degrees from here to here, this is a rotation of 60 degrees. This arc length is what is the number of radians. Okay, this is 60 degrees. Well, if 180 degrees is pi radians, if I take that and divide by 2, I get 90 degrees. So I take pi and divide by 2, I get pi over 2 radians. Well, what would we have to do to 180 to get to 60? Well, we would take 180 and divide by 3, so we have pi over 3 radians. Whoopsie. Oh boy, there we go. If I rotate 45 degrees, this is 45 degrees. We're looking at this arc length here for 45 degrees. This is going to be pi over 4 radians. I take 180 and divide by 4, I get 145 degrees. And then the last one we had that we dealt with was 30 degrees, which is, once again, we're looking for just this arc length in the interior of the circle. So this is 30 degrees, which is pi over 6 radians. Once again, hopefully you remember or have some sort of recall from what we did back in trig class with the idea of radians. The keys values to remember, we have 2 pi, which is 360 degrees. We had pi, which is 180 degrees. These are our radians. Pi over 2, 90 degrees. Pi over 3, which is 60 degrees. Pi over 4, which is 45 degrees. And pi over 6, which is 30 degrees. The key one to remember is if I have pi radians, I have 180 degrees. because with this we can have a conversion ratio. And with this conversion ratio, we have pi over 180 degrees is equal to x radians over theta degrees. So with this ratio, we can convert any radians to degrees or degrees to radians. Now it's really easy when I have pi in here and I'm trying to convert these to degrees. Because all we can do, or we could do, is we take this pi and we can slip in 180 degrees and divide by 3. 60 degrees, 30 degrees, and 45 degrees. Let's take the 150 degrees and let's convert these to radians. Now, if we take a look, we have pi over 180 is equal to x number of radians over 150 degrees. Okay, our theta value is 150 degrees. We can cross multiply and divide by the 180 degrees, so x is equal to 150 pi over 180. And if you want to clickety-clack 150 divided by 180, hit your math button, hit enter. This will reduce your fraction for you, or if you want to just cancel out the zeros, then I have 15 over 18. I can take 3 out of 15 and 18. So what we're left with is 5 pi over 6 radians. So if we have 200 degrees, we have pi over 180 is equal to x radians over 200 degrees. Once again, we can cross multiply and divide. X is equal to 200 pi over 180. The zeros go bye-bye. Then I have 20 pi over 18. I could take 2 out of top and bottom. So we're left with 10 pi over 9. If we go down to the pi over 12, we want to change its degrees. Now we're in radians. We want to change the degrees. Like I said, the nice thing about when we have the value of pi in there, when you have the value of pi, you can just slip into 180 and divide it by 12. We have 180 divided by 12, which is, it goes in one time. Then we have 60, so we have 15 degrees. Taking the 180 divided by 12. Go ahead, and what I want you to do is I want you to go ahead and do the rest of these here. Okay, so hit your pause button, do the rest of these, and then turn it back on. You can check your answers. 300 pi, we have 300 pi over 180 is equal to x over 300. So we have 300 pi over 180. Zeros go bye-bye. Then we can take a 6 out of top and bottom, so we have 5 pi over 3. Pi over 180 is equal to x over 50. And if you recall, when we're dealing with our radians, we use the variable of x. When we add degrees, we use theta. So we have 50 pi over 180. The zeros go bye-bye, so we have 5 pi over 18. Down here at the bottom, we have 2 times 180 divided by 3. Now what you can also do to do some mental math is you can take the 180 and divide it by 3. That gives me 60. Let's say this is 2 times 60, which is 120 degrees. If you remember, that was a way of being able to shorten it. 5 pi over 3, so we have 5 times 180 divided by 3. I could take the 3 into 180. That gives me 60. So we have 5 times 60. So we have 300 degrees. Then we have 9 pi over 4. So we can take this and divide. So we have 9 times 45. Take 9 times 45. Let's see, we got 5 there, 405 degrees. So hopefully you can recall some of the stuff from what we did in trig class. If not, hopefully a lot of the stuff will be triggered as you start going through this. I have a worksheet. I gave you a worksheet. I gave you solutions to the worksheet. Gave you some practice on this. Once again, this is our model that we will deal with right now. This gives us opportunity for notes. The hope is that you're taking your notes just like you were sitting in my classroom. Okay, you're just sitting there looking at your notes, and let's see, it's 9:13, so it's almost done. Time for class to be over with. So I'm going to close things out here. Stay safe. Keep your social distancing. Talk to people. FaceTime people. Excuse me. FaceTime people. Excuse me, allergies are starting to kick in. FaceTime some people, sit there and do some math work together, get yourself into a new routine in regards to the mathematics that we're covering here. If you have any questions, feel free to email me. I'll answer back to the comments. But once again, just keep a routine, find some time to sit there and do some classwork. Other than that, I have nothing else for you. Please do keep your social distancing. Let's get us back to normal, some sort of new normal. I miss you guys. I wish you were sitting in class right now, but that's our reality that we have at this point. So we'll make the best that we can do with what we have at this point. Stay safe. Adios. Have a great day.